Good morning. Today is our first lesson on systems of equations. So the focus on this lesson is really substitution and graphing. The other way to solve is elimination. So if we talk about substitution, we want to replace a variable. So we want to solve for a particular variable. So what we're going to do here is we're going to solve both equations for y. So I'm going to take my x minus y equals a -3, and I'm going to solve for y. So I'd have negative y equals negative x minus 3. Divide everything by a -1, and we get y equals x plus 3. Now I'm going to replace my y in the second equation with what I have here. So I would have x squared. This is where you have to be careful because when you're replacing y with x plus 3, you're going to need a parenthesis here so that you make sure that you distribute that negative through. So then I would have x squared minus x minus 3 equals a -1. Well, here we really have a quadratic. To solve our quadratic, we need to make it equal to 0. So we're going to add 1 to the other side. So we'd have x squared minus x minus 2 equals 0. Then we're going to solve our quadratic. We can solve this one by factoring. And we would have x minus 2, x plus 1 equals 0. So then we get x minus 2 equals 0 or x plus 1 equals 0. We set each factor equal to 0. We get x is 2 and x is -1. Now, when you're finding these points, you have to find an x and you have to find a y. Well, we know an equation to solve for y, so we're going to plug that x into that equation. So when x is 2, y is 2 plus 3, which is going to give me a 5. And when x is -1, I'm going to have -1 plus 3, which is going to give me a 2. So I actually have 2 points on there. And graphically, those are your 2 points of intersection. So let's look at another one. Again, this is a substitution. The nice thing with this one, they are already set to y. You don't have to solve. So really, you're just setting your 2 equations equal to each other. So we would have 3x cubed minus 3x squared plus 1 equals x squared minus 3x plus 1. Again, just like when we did with our quadratic, we want to set it equal to 0. We want to move everything on one side. So I'm actually going to subtract x squared, add 3x, and subtract 1. So here I'm going to subtract my x squared from here. I'm going to subtract my 1 from here, and I'm going to put my plus 3x over here because I don't necessarily have a term that matches with that. So all of these on the right cancel. That's going to leave me with x cubed. Then if I combine my x squareds, I'm going to have minus 4x squared. And then I would have a plus 3x, and your 1 and your -1 will cancel. Again, you have to factor this. But if you look here, they have a common term. They have a GCF. And so that is x. So that's the first thing that I'm going to factor out. And then what I'm going to do is I'm going to factor this inside part as well. So I need two numbers that multiply to 3 and add to a -4. So we would have x minus 3 and x minus 1. Actually, I don't know why I put a square there. All right, so set each piece equal to 0. So we'd have x equals 0, x minus 3 equals 0, and x minus 1 equals 0. Solve each of them. So we'd have x equals 0, x equals 3, and x equals 1. So again, you're going to plug these values back in. If you plug in 0, we would get 1. If you plug in 3, we plug that in, we'd have 9 minus 9 plus 1, which is going to give me a 1 as well. If I plug in 1, we'd have 1 minus 3, which is -2. -2 plus 1 is also 1. So in this case, we have 3 points of intersection. We have 3 solutions. This is another type of substitution. These are both linear. So if we want to do substitution here, I can solve actually this top one for x, and I would get x equals y plus 1. replace that x into the other equation. So I'm going to put 6, and then I'm going to put y plus 1 minus 5y equals 14. Distribute, that gives me 6y plus 6 minus 5y equals 14. And I have y plus 6 equals 14, and y then is 8. Once you have y, you can plug it back into your equation and find x. So your coordinate or your point of intersection is 9, 8. And that would be your solution. So notice that I'm writing all of our solutions as coordinates, x, y. We're going to skip that one. The next thing that we have here is using Desmos. So if you have a graphing calculator, you can use your graphing calculator. But to be able to graph these, we still have to solve them for y. So that's the first thing that I'm going to do here, is I'm going to take each equation and I'm going to solve for y. So I would have 2y equals x minus 1, and y equals 1/2 x minus 1/2. On the other equation, if I solve for y, I'd have y equals, and then I'd have negative 3x plus 17. So if you go to Desmos, and I'm going to stop share on this screen, and we're going to go to Desmos. Desmos will allow you to graph them and then find their intersection point. So you want to go to the Desmos graphing calculator. And again, if you have a graphing calculator, you can do it on there as well. You do not have to use Desmos. So I'm going to switch screens here. We're going to look at Desmos, and we're going to type in the two equations that we had. So we had y equals 1/2 x. Oops, we don't want that x in the bottom. And then minus 1/2. And so it graphs that one. And then graph the second one, y equals negative 3x, and then plus a 17. And then you can see here you have a point of intersection. And if I put my cursor over that, you can see that that point of intersection there is 5 and 2. And that would be the solution to my problem. So any of these you can graph to check your solutions, even if it asks you to solve them algebraically. So I'm going to switch back here. So again, your solution here was 5 and 2. We can also do this algebraically, and we could say set our two equations equal. We would have 1/2 x minus 1/2 equals negative 3x plus 17. If I add that over, I get 3 and 1/2, which is really 7/2 x equals, and then that would be 17.5, which is really 35 over 2. And then when you divide, that would give you an x of 5. Again, if you plug that back in, say to this equation right here, you would get a y value then of 2. And you can see algebraically, you're going to get the same solution as you do graphically. But Desmos is very nice. It's even nicer than a graphing calculator because it actually shows that point of intersection, and you can just click on it and find the solution or solutions depending on how many times they intersect. If you have any questions, please make sure that you email me. I'll be happy to help. Have a great day.